So again, welcome everyone to the weekly meeting. Nice to see you all. As always, add yourself if you got some quick reports to go through. It'd be great. I don't have any particular agenda items again this week. If there's anything anyone else would like to discuss with everyone as far as like big picture stuff, add it and then we can go through it after the quick reports if you like. If not, let's kind of go nice around. Everyone's going in. So I see Soggy has added things, but he is not on yet. Lindsay, do you mind going next? Giving a little bit of an update on anything governance stuff. It looks like you got something in there.
Sure, mostly just a quick request if folks could take a look at the governance pull request. It would be great if you have any suggestions for changes, please feel free to make those suggestions or comment on the pull request. If you're happy with it, it'd be great to just get an indication from folks. So either like approve the pull request or thumbs up the pull request or something like that, just to get sort of an indication of broad consensus in the community. So yeah, whenever folks have a chance, but it would be great to get that sort of formally in and we can move on to the next steps there. That's it.
Devin, do you mind going next then?
Yeah, I put in some work over the past couple of days to fill in the doc strings, kind of do the auto generation of API stuff for Discretize. So got my way through all the utilities, made examples for all of them as well to show how they work, and so that's a pretty good final draft for that, and try to move on to documenting the classes in Discretize next.
What branch are you working off of?
I believe I'm working off of something API docs something. Let me find. Yeah, NumPy docstrings _ API, and I've kept up with, I guess, the dprop that you had. So yeah, I haven't done anything with PyData retheme. And we can talk about maybe making sure that I'm up to date with whatever the latest is for the package. There's no point in documenting things that don't exist anymore or are changed.
No, that's fine. I think I got everything merged in relative to the new, like the most recent release of Discretize, so it should just be working off of that. Like, it looks like it's working off of that now. So
okay, so I'm up to date then.
Looks like it. Yep.
Yeah.
Cool. I'm looking forward to getting that in. It'll be a nice thing to have all the classes like fully documented. It'll be great.
Yeah, well, once that happens, there's still tutorial stuff that's been hanging on. So several months ago, we kind of went through a review of that and then realized, okay, we need to make changes to the code, and then that's kind of hanging around. Yeah. But a lot of work has been put into that. So
I think the necessary code changes are there now to kind of finish off the tutorials, like those like longer tutorials that you had.
Okay, I mean that might be something I'd consider working on. I got a review, and there's a couple functions that I couldn't do to kind of make a comprehensive tutorial of certain things, but it sounds like I could do that now. So it seems like something that just needs to get pushed over the finish line, and I'd like to bring that in pretty quickly as well.
Yeah.
If I could.
Okay.
Do you see any big concern with kind of working on those two things simultaneously on the same branch, or do you really want to keep them quite separate?
Let's keep them separate.
Separate. Yeah.
I mean, one is like directly modifying the code, right? The other is just creating tutorials outside of it. So let's just keep them separate for now. It's a little bit easier.
Yeah. Okay.
Soggy, I see you popped in here. Do you mind going through the quick report items?
Yeah. So yeah, for last week I worked on that 1D code refactoring. So yeah, I finished it on my end. So I passed that over to Joe and Dev. And yeah, so now it's actually using the existing source and receiver class for the 3D code. So like you can actually run about the same simulation in a very similar way. So yeah, if anybody interested, have a look. I think it's not it's not very elegant at this point because I had to dump all the variables into that the existing EM surveys. So probably need a couple more iterations, but the mechanics are there. And yeah, so initially I probably need to, like, I thought like we need to sacrifice the efficiency, but yeah, I didn't like that. So I spent some time to actually optimize under the hood. So it's actually, yeah, it's actually better than the previous version. So it's actually nice. Anyway, so that's what I worked on, and that's done on my end. So I think, Joe, actually, have you had a look at the that's like variable offset issue in the RTA function? I think once that's
Yeah,
figured,
I was thinking more, trying to think a little bit more about it, and just kind of, I think we could implement some smart broadcasting information, like smart broadcasting there, to kind of make it work in both cases.
right? I think once that's solved, I think then the current 1D code can handle, like, I think that all airborne systems, I think, because that was the only exception.
Yeah, so right now, like, you can definitely have it do multiple offsets, and it
That's
does
true.
it, like you can, but I think the simulation there is that it'll compute, right now it'll compute like everything needed for everything, but it's not all needed, right? Like you only need a certain numbers of them. So it's like,
Yeah, the thing that we're talking about in 1D, like that the reflection coefficient is not dependent upon that your offset, as well as so if your source and receiver are at the same plane, it doesn't matter. So that doesn't change. So if you actually can combine all of the offset into a same place, you can just compute that reflection coefficient once. Then, so I think in such a way you can actually optimize the code. So that was what's related to that.
yeah. Yeah, I think we can, if you're talking about that, I think we can work that together and figure it out.
Yeah, but it's pretty minor though. I think that resolve actually it's all same. So I think probably the most cases it doesn't really matter. But I thought that could be nice to have that option. And a couple other things I met up with Nick about the CSAMT. So I was working on Dieter about that frequency domain code. And one of the potential application that I thought could be the CSAMT. So Nick seems pretty excited about that. So he's going to provide us kind of good CSAMT data. And what's I thought interesting is the setup for CSAMT is basically using the MT codes. So they don't really like the typical vendor seems like the Quantac. And it seems like people don't really keep track of where the source locations were because your interpretation method is the MT code. So they don't really care where the source was. So a lot of the historical data doesn't actually have the source location, which I thought interesting. So this is another case where your interpretation method kind of constrains your design of the survey, which is actually not good. Anyway, so I think we're going to get a data set from Nick and we're going to work on that. And related to that, I think it was Mike who worked on the wireline source. So we initially implemented that, but still not quite available. So I made an issue and I'm going to work on basically finishing that up. And what's actually nice is once you got that source, actually the adjoint is the receiver. So you can actually have both wireline source and receiver with the same function. So I'm going to work on that, and Nick Sim's interested to using that to calculate the EM effect in the IP data. So yeah, it might, yeah. This is something that I'm working on as a side project, but I'm excited. Yeah, that's where I am.
Yeah, from what I remember about the line source branch was like it was already, it seemed like it worked, like it passed all the tests that I had locally, but for some reason it was having some weird memory issue on the when testing in the cloud on their computers. So I think I can go back. I need to run it through my own Linux machine and see if I can reproduce that error and then try to track it down.
So I rehashed, like I
Yeah.
went into that branch and took some of that code and implemented there for the forward modeling for CSAMT that I did there just recently. So it hooks in right, like perfectly.
Yeah, it should work. Like I just don't know. Like it's causing this random, really other out there test that has nothing to do with this to fail, and it just runs out of. Like it just hangs. Like the test just hangs, and then it gets canceled after 50 minutes or something.
Yeah, I'm also happy to test Joe. So I'll just like take a look and try to use it and see if I can make it.
Yeah. Like I said, it's the test has nothing to do with the line source at all. It's just really
Yeah.
doing it.
Right. Yeah, then I'll focus on actually implementing the code and testing for an exam.
Yeah. I just need to figure out what's making that test fail and fix it.
And potentially, if you guys are working on MT problem, thinking about using that wireline source to generate the magnetic field, because in that way, you don't really have to project on your electrical field into a magnetic field. So it could save quite a bit of projection part. Anyway, just that. It was just a thought.
I thought the purpose was to like use the discrete operators, so it's still like divergence free when we're doing that. Like, because if it's like an exact solution, we end up with some like numerical dispersion or something.
Not sure, Joe, what we're actually talking about.
I just remember looking through all the codes, like the frequency domain source codes, and seeing notes about, oh, we do it this way because otherwise there's going to be a little bit of dispersion or something. We're like just using it to keep the discrete operator instead of like actually computing B.
I think that's for the vector potential, Joe, I guess, for the because if you use the like a magnetic field directly for your source term, it doesn't kind of make sure your divergence free condition. So by using the vector potential, we actually make sure. And actually that makes a big difference in in the magnetic source.
So that was the only thing I was referencing then.
Yeah. Got it.
Okay. Let's see. Dom, what have you been up to?
A few things, but John, before I go myself, so the line source things that you've pushed on our tiled simulations branch, is that exactly what Sagi is working on?
I don't like it would have been in the branch. I thought that Mitch and
Okay, so you merged this in and then okay, got it. Yeah, so the styled simulations will we'll have to parse it apart and bring it in chunks because it's getting pretty Frankensteiny. But it's good. I mean, we're doing progress. But
I've been curious with the CSAMT with Dias, so we've been playing around with it, and it just was so natural to go with that branch because everything.
I know.
So is it a matter of it's just that you guys have been pulling other branches into it? Because if that's all it is, then we can just merge those other branches in the master and it'll be easier.
Yeah, but also like there's like when you look at the diff files, like there's a lot, right? Most of it isn't tested, so we should probably just bring it in chunks and add tests for each part of it at once.
Okay.
Like we refactor the receivers. There's a lot of DAS stuff that's going to be on its own, but yeah, it's sprinkled. So I think it will be safer to spend time bringing
Yeah, I
it
brought all
slowly.
the MT in there too. So yeah, there's quite a bit.
Yeah, so I just started so I branched the fork tide simulations back to the SimPEG tide simulations branch, and then I started adding an example for you, John, so that you can look at how to break up like the MT in frequency and spatial at the same time. I saved a little bit of time. I think I can generalize it a little bit more, so that we're not using like frequency words, but more just like components, basically reshaping the data and then slicing it, right, in a smart way. So that's what I'm done now. And then another one, you guys might have seen my rant on the GravMag channel, but I reviewed a paper that could really streamline the MBI, the sparse MBI. So I will be probably implementing a mapping to do this. Be able to keep it in all in Cartesian system. So that's pretty exciting. That should really ease the runtime for the MBI. That's going to be next week though. And that's it. That's it for me.
John,
Yeah,
leading right into that.
yeah, nothing too much more to add. I modified the tipper receivers so that they can take a roving Z and a stationary XY. That's all pushed onto, actually that's on tiled right now, not on the MT one, but I can pass that over soon. Yeah, it's already starting to be a mess. And yeah, I was talking with Dom yesterday, and yeah, we'll probably start breaking the tiled simulations apart and get the test passing and get that hopefully pushed in the near future. And then, yeah, I'll post the Kubernetes cluster instruction. I just have to find the instruction that I used for the RSA keys just to make sure that I have it right. It's been a few months now, so of course, a little foggy. So I just want to double check that. But yeah, that's about it.
Hey, John, I tried right with the station. How do you call that? Not the rover, but the
Stationary.
the reference, whatever reference station, right?
Yeah.
The inversion really pulls towards it. It's kind of like a it's a big sensitivity.
Exactly.
Yeah.
I was trying to do that with our kind of doing the full MT with the airborne, and but we have that stationary E and X.
Yeah,
and
you were saying.
I've made like one, or I just take the sensitivity from one frequency and use that as my weighting, and that's helping a little bit. But I don't know, the inversion at that point was still going pretty slow, so I haven't revisited that in a while. But yeah,
Yeah.
it just sucks it right to it.
I guess I will need to test right too if it really changes the solution. If we put if we compute XY at every point, or we really use the base station. I don't know. Sagi, you seem to think that the fields were smooth enough that it wouldn't matter. I don't know.
I'm pretty sure that is the assumption. Yeah.
Well, that is the assumption in general. Like if you think about the 2D code, it's impossible to put a right reference location. So their typical assumption is magnetic field is smooth. So they just attach magnetic field, whatever a receiver location, and compute that tipper, I think. Maybe, that may have better idea because I think they have dealt with this problem with the ZTAM, I guess. So yeah, so I don't know. It seems pretty clear that if you have a same reference point, then you got really high sensitivity to that point. But I think the reference location is usually pretty far from your core domain, I think. So it's probably doesn't really matter even if you put like zillions structure there, I guess.
Well, yeah, not necessarily. It can be inside the survey too. I'm not sure.
Oh, really? Oh, I didn't know that.
Yeah, I think they planned for far away, but it never really like it's still close enough that it affects things. The test that we did, we thought we had it far enough away, and no, definitely not.
Okay. A little update from my end. I've added tests on for all the boundary condition update stuff for the DC problem. I have working Robin boundary conditions for the nodal DC problem right now as well. So it actually handles pole receivers very well. Like I've just kind of looked at it, so it handles it much better than it did before. Because like technically you couldn't actually solve it with a pole receiver because it just violated the assumptions that you have to make. So it didn't work. It shouldn't have worked. Like it worked, but it was not right. But now it works really well with pole receivers and just kind of in general. So it'll be a good thing to have as like the default boundary conditions for both of the cell-centered and nodal problems. It looks nice. It has nice solutions.
That's awesome. Which
Sounds
branch
very
are you
cool.
working on, Joe?
The one that I have a pull request up on, it's like
That's a SimPEG or discretize?
SimPEG.
Gotcha.
Yeah, and then I added a few things to kind of cache some of the matrices in 2D, so they build a little bit quicker. Just because they're dependent on the spatial wave number. So just a few little inside things that happen that cache it there.
Awesome. So then, Joe, is that DC code is check? It's done. Like it's good enough to be published. Is that?
Yeah.
Perfect.
We'll be happy with it. The only thing that's out there is that the nodal problem with that boundary condition, like that Robin whatever linear combination boundary condition isn't set up yet to handle like an anisotropy. But that's the only thing.
I think that seems fine. I think that's general assumption made. So Joe and I talked about writing up a DC paper. I thought like it's actually in quite good shape. Like kind of talking about versatile, multidimensional DC code and can handle various types of regularization functions and kind of different types of inversion approach. I thought that could be quite a valuable paper. So yeah, we're gonna write it up. Joe will lead that. So I'm excited.
Where are you thinking to send that?
We like maybe computers and geoscience. I think something like that. That would be better. I think
that's kind of the idea. But it's actually neat because with the nodal boundary condition, with that like mixed type boundary Robin, whatever, it actually has to go into the derivative of the matrix because of the way that it works out. So it's interesting.
Yeah. And likely we probably kind of emphasize that use LP norm and parametric inversion and that types of things, and then emphasize the ability to handle all dimensions. I think that's pretty unique. I think only PyGimni can handle that, I think.
Other than that, I got the presentation recorded last week that I was talking about. I think it'll be well. It's going to be given. I think the date is next Wednesday at that parallel CFD conference. We'll see how it goes. Just kind of went for it with the recording, so it'll be interesting to watch myself back again. Always weird.
Can we actually see that, Joe, or do we have to register for the conference? How does that work?
I think you'd probably have to register for the conference, but I'll look more into it and see if I can share it a little bit. Thibaut, do you have anything? I see kind of started writing a name and then nothing.
Oh, really? Did not update? Let me check the notes. I thought I wrote
Okay.
something, but
Here,
anyway, I just wanted to say that I done my cake talk yesterday. I think it was successful. At least we have sparked some conversation on the SimPEG Slack, so that's good. Like some conversation from Nick in the threads are also like I saw this morning from from workers about like community engagement and documentation and tutorial dev. So yeah, that's about it for me for this week. Was yeah, I think it was a success in terms of like attendance and bring home message.
I think I heard it was the highest attended so far.
It was.
good, good. Is anything else anyone wants to chat about? Chat through some things?
Oh, I put a link. Some of the airborne data that we have worked on is actually publicly available. So yeah, technically you can download and use. I'm not sure the data is in the form that is usable, but it's there. So anybody interested actually can use it. So have a look. It's probably a mess. I didn't archive that data, so it's not my fault, but the data is available. So
is that airborne? Is that data
yes.
over?
Yeah.
With the stuff you're using?
Yeah, it's all of the data, like all the well data, airborne data, and whatever the data they have collected throughout that project. So yeah, yeah, it's actually expensive data. So anybody interested, have a look and use it, because it does a lot of money that they spent for this project. So
Cool. Well, then, is there anything else?
Shalom, question for you. How far are you in your cross gradient? I see that your PR is still open and hasn't moved since December last year, right?
Yeah.
I would be interested in probably start using the cross gradient at some point. So do you need help to push this ahead, or?
Also, you mean sorry.
Finish the pull request, right? Because right now your branch is behind. It looks like it needs to be updated, and then we could help you maybe merge this into SimPEG Main at some point.
That sounds good.
Yeah. So would you mind just updating your pull request right now to make sure that the tests are running, and then we can have another look at it maybe?
Yeah.
How does that sound?
Yeah, that sounds good.
Okay, sweet. Because I think we don't want to lose it. Like we want to make sure that it comes in. Yeah, sooner the better for me.
Yeah.
I'm just gonna mention too that the PGI has been passing tests since December as well.
Oh yeah, how come you're not in? That's crazy. Yeah, now they're failing. It looks like, but.
Yeah, I don't know. It's like updating master. It was passing tests before, and I think now it's just like missing like a 0.01% of coverage, but it was passing before. So it's like it was passing tests before, and now updating master is not passing. So I don't know. I think it's just a coverage of like a few 0.1%.
So do we need some sort of protocol here? Because I can see, I mean, it's all of our fault. What's actually our protocol to merge a pull request to a main? Like it seems like the minimum is an approval from a reviewer, and do we have actually a protocol to merge something into main? And this is something that we probably need to think through a little bit more, and at least set that
It's certainly
It's,
easier to
otherwise-
understand with the smaller pull requests because it's like, oh, it's just a simple line change or simple changes here and there. It's easier to understand, easier for us to see, but it just takes longer with the larger ones for people to look through them. It's like, okay, well, there's certain things that certain people have access to. I think it's at the stage where we should probably just pull in the PGI pull request as well as, so that way we can get the cross gradient one updated to be relative to that one. I think that's what we should just do, and we'll work on that. I'll work on that today, tomorrow. I think the few tests that we're failing on the PGI now are related to the renaming of master to main. Looking at it, so.
Thanks, Drew.
And I think I had that handled in my DC updates. I just switched it around. So we'll get them in this week. We do it.
Great. So yeah, you're saying PGI first, and then we'll update cross gradient, or
Yeah.
can Shalom update cross gradient? Because you're working on a fork, right, Shalom? You're pushing stuff from your own repo. Is that correct?
Yes, that's correct.
Yeah.
Yeah, I think there's just the structure of a few folders and things changes a little bit from what I remember.
Yes.
So it's just a matter of updating that and keeping them consistent. Okay, then let's get to it.
2 thumbs up. All right. Is that it?
That's all I've got for everyone.
Wonderful. Have
Thanks,
a great
everyone.
week. Bye-bye.
Bye, everyone.
Yeah.